Greetings, my wonderful scholars. I'm your online physics teacher, Mr. Okafor PC. Our topic of discussion today is the concept of force and the concept of pressure. Force versus pressure. From time immemorial, mankind has been puzzled on why objects around them move or stop. Why do things move and why do things stop moving? Many great scholars from past have attempted to put solution to this question. And one of these scholars was Aristotle. Aristotle argued that things move because it is in their nature to move. He also said that things stop moving because they get tired of motion. Things move because it is in their nature to move. And they get tired of motion. That is why they get to a point and stop. So many other scholars tried giving answer to this puzzle. After several years, around 17th, 18th century, a scholar by the name Sir Isaac Newton argued that things don't just move because it is in their nature, that something is causing the motion. Isaac Newton argued that there is a cause that brings about motion. For Newton, motion is an effect caused by something within the body or outside the body. Newton was seeing a cause responsible for the effect of motion. So for Newton, something inside the body is causing the motion, or something outside the body is causing the motion. Newton argued that the apple hangs on the apple tree because the tree is supporting the apple. The tree is holding on the apple. Newton also argued that the apple falls down from the tree because something outside the tree is pulling it down, and that is the Mother Earth. For Newton, there is an agent inside the body or outside which makes the body to move. So Newton explained that things move because a force is causing it, and things stop moving because a force is causing it. So Newton initiated the idea of force. Sir Isaac Newton argues that force can be defined. A force can be defined as an agent which is either inside the body or outside the body or in the body's environment, which is responsible for the reason the body is either moving or why the body is at rest. A force is an agent inside or outside the body which causes the motion or the rest position of a body. Take for instance, the airplane. The airplane, the pilot maneuvers 4 forces. Two of these forces are coming from the plane, while the other two are coming from the environment where the plane is situated. Newton's arguments: force is within and outside and is responsible for motion. If vehicles are moving, the engine is responsible for the motion. Therefore, the engine is the force. If vehicles are moving, the engine is responsible for the motion. Therefore, the engine is the force. Okay, take for instance, if your mother is the reason you want to live a successful life, then your mother is the force in your life, is the driving force. In the universe, force is control matter. Forces control matter. It can also be your background that is the force that is driving your conduct. So force is what makes a body to move, according to Sir Isaac Newton. Okay, let's go back to the plane analogy. The two forces coming from the engine of the plane are the lifts and the thrusts. They come from the plane, from the engine of the plane. The engine creates lifts and thrusts. Then the two forces coming from the environment where the plane is situated are the drag or friction and weight or gravity. This is Newton's argument. Something is causing motion. Something is bringing about rest effects. It's not just in their nature. We need to study their nature and see what is causing that, and that is force. The apple falls down from the tree because of the Mother Earth pulling on the apple. When the stalk connecting the apple to the tree gets weak, the Mother Earth pulls the apple down from the tree. So it's game of forces. In our universe, in our world, in our earth, it's game of forces. And Newton went further to explain how this game is conducted. Newton says, because it is still facts, Newton argues that it is a force that keeps a body at rest. Then Newton says, if another force must make that body to start moving, that other force must pay a price. And Newton says, the price is that the new force must give the original force equal magnitude. It takes equal forces to cancel. In the first argument, Newton argues that if force of 10 Newton is holding a body, that it can only take another force of 10 Newton to come and cancel that force of 10 Newton to free the body. For force to cancel another force from holding a body, they must be equal. Okay, take for instance, let's go to social setting. If there is snares in a showcase, and the price of the snare, the cost price is 1,000 naira, it can only take 1,000 naira to free the snares from the showcase. When you give the seller 1,000, the seller releases the snares to you. Then Newton continues that forces of equal magnitude or equal number will cancel. And when they cancel, that body is now free. But understand the pattern. Understand the pattern of freedom in this body. Newton said that the body tends to be at rest or in uniform speed or velocity. Please pay attention. When equal forces meet, then they will cancel. The body will not be at rest, or the body will be in uniform velocity or speed. I've said it before. The idea of uniform speed or velocity is the same as the idea of rest position. When two forces cancel, the body is free, but the body will not increase in speed, and the body will not reduce in speed. The body will go at the same speed because the body is now at rest. Take for instance from the board. When the thrust is 10 Newton and the drag is 10 Newton, the forces will cancel. There is no force acting on the plane again. The forces have cancelled. The horizontal plane, there is no force on the horizontal plane again, they've cancelled. Then the plane begins to move at uniform speed. If the speed is 30 meters per second, the plane maintains this speed all through. And this is why passengers in the plane don't know that the plane is moving, because the plane has maintained uniform velocity. This is why airliners inside the earth don't know the earth is moving, because the earth maintains uniform velocity. In uniform velocity, we don't notice motion because the forces have cancelled. Then paying attention, when forces cancel, the effect is uniform speed or rest position. The body is either at rest or in uniform speed. Then take again analogy this way. When the plane is about landing and the gravity is 20 Newton, then the air pushing against the plane, that's the drag or air resistance, also 20 Newton. Then the force is cancelled. There is no force acting on the plane. So the plane begins to fall down with uniform speed. Let's also presume 10 meters per second. So this speed is fixed. The speed does not change. It does not increase, it does not reduce. Uniform speed. And that's what we call terminal velocity. Terminal velocity or terminal speed, also called uniform speed. When uniform speed occurs in fluid, gases, and water, we call it terminal velocity. This is where force is cancelled. Terminal velocity. Then Newton continues. But when unequal forces meet, something happens. The bigger force wins the smaller force. Force of 10 Newton, force of 15 Newton, they encounter. That the force of 15 Newton will win 10 Newton with 5 Newton. 15 minus 10, 5 Newton. Newton called that 5 Newton resultant force. And Newton said that this resultant force will not permit the body to move in uniform speed. That the resultant force will make the speed of the body to start increasing. And that is the term acceleration. So a resultant force causes acceleration. Newton argues, resultant force brings about acceleration. See, when you go to a seller to buy snares, and the cost price is 1,000 and you pay the seller 2,000, the seller will give you the snares and also give you gratitude, appreciation. The joy will increase. The joy of selling is there, and the joy of bonus of gaining free money is also there. So the speed will increase. When force of 10 Newton, force of 17 Newton encounter in opposite direction, the force of 17 Newton will win the force of 10 Newton with 7 Newton. That is, 7 Newton is resultant force. Then the speed will never be the same. The speed will do what? Increase. And anytime the speed increases, it's called acceleration. Therefore, the higher the resultant force, the higher the acceleration, the increasing speed. The lower the resultant force, the lower the what? Acceleration. But when the forces become equal, there is no acceleration. In other words, when the resultant force is 0, the acceleration is what? 0. Take it again. When the resultant force is 0, the acceleration is what? 0. That implies that the forces are now equal. Therefore, that will also imply that the body has uniform velocity. When forces equal, uniform velocity. When forces are unequal, resultant force, acceleration. That's the logic. If I have a table of 5 Newton and I insert force of 5 Newton on the table, I've cancelled the force. Then the table will either be at rest or begin to move in uniform speed or velocity. 5 Newton, opposite direction. 5 minus 5, 0. The body is either at rest or in uniform velocity or uniform speed. Then table of 5 Newton, I apply force of 8 Newton. 8 Newton going against 5 Newton. I will win the table. The table will begin to accelerate because the resultant force now is now 3 Newton. The table begins to do what? Accelerate. Okay, let's go mathematical to see what Newton is saying. Newton is saying that the resultant force is proportional to acceleration. That the higher the resultant force, the higher the acceleration. Lower the resultant force, lower the what? Acceleration. Then ask yourself, what is the constant? When I was pushing the table, there were two variables. The force I was giving the table and the change in speed that happened in the table. But the table remained intact. The mass of the table is the same. I didn't put anything on top. I didn't take anything away from the table. Therefore, the mass of the table is the constant. Therefore, F, take away a variation sign equal to, introduce a constant. This time is direct proportion. K, then A. Then recall the constant here is mass. Therefore, F is equal to ma. This is Newton's equation, where F stands for force, M for mass, A for acceleration. Then let's get the units of force, because force is a physical quantity. Therefore, it must have units. From the formula, for finding mass, kilogram. For finding acceleration, meter per second square. This can also be kilogram, meter per second square. This is the SI unit of force, kilogram, meter per second square. 1 kilogram, meter per second square can also be called 1 Newton in honor of Sir Isaac Newton. 1 kilogram, meter per second. 1 kilogram, meter per second square. Forgive me. 1 kilogram, meter per second square is synonymous, or is the same as 1 Newton in honor of Sir Isaac Newton. Then the question becomes, how does force relate to pressure? You're paying attention. When force is applied on a body, we are concerned with the area that the force covers on the body. When force is applied on a body, the area of that body covered by the force is our concern. Then the force will now bear a new name. Since the force has been applied on a body, the name changes from force to becoming what? Pressure. So pressure is force applied on the surface area of a body. Pressure is force applied on a body. Anytime our force is applied, the name changes from being force to becoming what? Pressure. So pressure is advancement in the concept of force. This is why we're doing comparison between the two. Okay, take for instance, there's a popular question in external exams. A man standing on both feet. A man standing on 1 foot. A man standing on 5 toes of 1 foot. A man standing on a single toe on a foot. Who is at a greater pressure? Okay, we need to understand the concept of pressure to be able to answer this question. Okay, let's break in attention. Recall, when force has been applied on a body, we are concerned with the area that the body has surface area, but we're just concerned with the area within that body where the force is acting on. That area now is our concern, and the force on that body is our concern. When we study what happens there, we are studying pressure. Therefore, pressure is the force applied on a given area of a body. Mathematically, P is equal to F over A. This simply means pressure is force acting on given area of a body. Then see the idea we want to communicate here. The higher the pressure, the smaller the what? Area. The smaller the area, the higher the pressure. Please, let's be careful with things that are pointed. Very pointed objects have high pressure. It takes a smaller area to create a very high pressure. Okay, let's go back to our former example where a man stands on 2 feet, 1 foot, 5 toes, 1 toe. The man with the highest pressure there is the one standing on 1 toe of 1 foot. Because the entire body weight is now acting at a very small area within the body. And this can cause the man to fall down from the surface of that body. That reminds me, no wonder roof engineers, they try to always stand on both feet at the rooftop. They want to balance the body weight on 2 feet. Because 2 feet will bring about a larger area, thereby reducing their pressure, preventing them from doing what? Falling. Notice roof engineers, they try to balance the body weight on 2 feet. Balancing the body weight on a single toe on 1 foot means small area, which also means high pressure. No wonder the knife is pointed, because the knife targets to cut through food items. Therefore, a smaller area will mean a very high pressure. This is why it's very easy for the knife to cut through food substances. Because the surface is very small, the pressure will be very high. Pressure is like cutting effects. Pressure is like cutting effects. No wonder the airplane is rounded or pointy. The nose of airplane is either rounded or pointed. This is to enable the plane to cut through the air, because the air is like a membrane. The air is like a membrane. So the higher the pressure, the smaller the what? Area. Just imagine an airplane that has the design of a car. Do you think flying will be possible for that airplane? The air resistance or the ground force will not permit it to move. So the plane must be streamlined, and that is the idea of pressure. That the plane must have rounded or pointy nose to cut through the air. Very high pressure, very small area. So we have to be careful with pointed objects. That is why compacts, dividers in a mathematical set are enclosed within the mathematical set. Because they have high pressure, they can serve as weapons. So to improve the safety of students, they must be enclosed. That's why the pen must have pen cover, because of its pointy nature. Anything pointed has high pressure. And to ensure safety, we'll cover those pointed parts of those materials. The higher the pressure, the smaller the area. Then notice the constant of proportionality. This one I was gotten from P is inversely proportional to what? Area. The higher the pressure, the lower the area. The higher the area, the smaller the what? Pressure. Okay. Like we argued with the man on 2 feet, 1 foot and thereabouts. Recall, the same man was varying his pressure and area. The same man with the same body weights. Therefore, the weight is constant. The force is constant. Weight is a force. The same man on 2 feet, 1 foot, 5 toes, and 1 toe on a single foot is the same man. Therefore, the weight or the force is the same. Then our constant of proportionality here is the man, which is the force or the weight. Therefore, P. Then we'll take away variation sign equal to K over what? A. Recall the constant is the body weight, force. Therefore, P is equal to force over area. The smaller the area, provided the force is the same, the higher the what? Pressure. The bigger the area, provided the force is the same, the smaller the pressure. Okay, in summary, recall, pressure is applied force on a given area of a body. Don't forget that pressure is a physical quantity, therefore there is need to derive its units. Okay, let's see from the board. The unit of force, Newton. Unit of area, but before them we have over, per. Unit of area, meter square. So pressure is measured in Newton per meter square, which can also be put this way. Newton meter raised to power minus 2, which also Newton per meter square. We have other units for pressure. Units like Pascal. capital P, in honor of Blaise Pascal, whose impacts on the findings we have on pressure cannot be neglected. Blaise Pascal. We have a law called Pascal's law of pressure. With time we learn more of these physics concepts and theories. But for now, why Pascal is honored is because of his intense research on pressure. Just like Isaac Newton with force. The SI unit of pressure can also be called Pascal. 1 Newton per meter square is the same thing as 1 Pascal. 1 Newton per meter square is 1 Pascal. We have other units like millimeter mercury, centimeter mercury, and atmosphere. ATM. Okay. The air in the Earth's surface is that pressure on anything or everything on the Earth's surface. This is what we call air pressure, atmospheric pressure. Pressure in the Earth or air. The atmosphere of the Earth is that force on everything towards the Earth's surface. And that pressure has been quantized. That pressure has been measured. And the value X. Pressure of air on anything at the Earth's surface X. 760 millimeter mercury. This is how much the air is pulling on our head, is pulling on water surfaces, is pulling on our building. 760 millimeter mercury. Provided you are at the surface of the Earth. If you want to reduce this pressure, what do? You go high. This is why the airplane goes high, to reduce the air pressure on it. This is also why eagles go high, to reduce the air pressure on them. So when you go beneath the Earth's surface, the more the pressure. When you go underwater, the more the pressure. The pressure of water plus the pressure of air begins to act on you. Swimmer experiences two pressure. Pressure of the water and pressure of what? Air or atmosphere. That of the atmosphere is 760 millimeter mercury or 76 centimeter mercury, which is equivalent, or 1 atmosphere, which is equivalent. So air pressure is 1 atm on Ox. ATM standing for atmosphere, pressure of the atmosphere, which is synonymous or equal to 76 centimeter mercury or 760 millimeter mercury. In summary, things don't just move because it is in their nature to move. Things don't just stop because it is in their nature or they get tired of moving. Things move because something is causing it. And that cause, that agent is force. And that force can either keep the body at rest or make the body move. When another force wants to battle a force keeping the body at rest, two things are involved. If a force wants to make a body at rest, being kept in that condition by a particular force, when another force wants to alter it, it will pay two prices. The first price is this. It's either it will equal it. It's either the new force equals the original force keeping the body at rest. And when it equals it, the body is at rest and the body is also in uniform velocity or terminal velocity for fluid. But when the new force is more than the original force, then we have resultant force. Then the new force will now control the body and the original force will seize the control. So the new force wins the original force with a resultant force. And that resultant force will now make the body to now accelerate. A resultant force is the force causing acceleration. If 10 Newton force is keeping the body at rest, 12 Newton force in opposite direction will cancel the 10 Newton with force of 2 Newton. This 2 Newton will now make the body to accelerate. Therefore, since there is acceleration, that 2 Newton is now called resultant force. The SI unit of force is Newton. When force is applied on a given area of the surface of a body, we call it pressure. And the pressure increases with smaller area. And the SI unit of pressure is Pascal, Newton per meter square, millimeter mercury, centimeter mercury, and atmosphere. The pressure of air, atmosphere of the earth on our head is 760 millimeter mercury. Thank you, my beloved viewers and learners. Stay tuned with us. I bet you won't regret it. Please focus and do subscribe. Thank you very much.